Hi, I'm going to show you another example to graph a quadratic when it's in vertex form, this time when your a value is negative. So let's go ahead and look at the general form again of a quadratic equation when it is in vertex form. We have our a value in parentheses x minus h squared plus k. So the first thing you want to do in this example here on the left is identify your a value. So our a value is -2. Now here's the tricky part where students get sometimes confused. The h value is 1. So this means when you're looking at your x minus 1 squared, look at the general form, it is x minus h. So the h value is 1 and the k value is -1. Once I know my h and my k, in other words, the values that I am showing you right here, that is my vertex. So my vertex happens to be 1, -1. First thing I want to do is place that on the graph. So if I go 1 to the right, 1 down, I have a vertex point right at that corner square. All right, if I know my vertex, then I know my axis of symmetry. So if you saw the last video, I explained that the first value of your axis of your vertex is always the axis of symmetry. So you should write it as an equation, and that equation is a vertical line in this case. So it is x equals 1. So I'm going to go ahead and I'm going to draw the axis of symmetry, which always goes through the vertex. So I'm going to draw the axis of symmetry going through the point 1, -1. All right. Next, what I want to do is identify one point on the graph because I know, and as I mentioned in the last video, any points on the right of the graph, whatever the distance is right, then there's an equal and opposite point reflecting on the left. The easiest point to plug into this quadratic is 0 for x, which happens to be a y-intercept. So if I plug in 0 to this equation, y equals to -2. I have 0 minus 1, square that, and then we will subtract 1 from it all. Now remember, you should always use order of operations. So the first thing you should simplify is inside the parentheses. 0 minus 1 is just -1. So it is -2, -1, square that, and then -1. All right. Next, what you should do is you should always use your exponents first. Exponents before multiplication. So I have my parentheses squared. So -1 squared is 1 times -2. So what I have is 2 times +1, because -1 squared is +1, -1. Now, again, using order of operation, you always multiply before you subtract or add. So -2 times 1 is -2. And then I'll bring down that -1. And then when I combine -2 and -1, we get -3. So our y-intercept is y equals to -3. And that, of course, is when x is 0. So let's go ahead and place that on the graph. So 0, 1, 2, -3, my y-intercept is right here. And I can actually write that as an ordered pair. 0, -3 is my y-intercept. It happens to be below the vertex. Now, this makes sense since you look over here, our a value is -2. When your a value is negative, that will flip the graph. All right, as I mentioned in the last video, the axis of symmetry is my line of symmetry. So if I have a point 1 unit to the left of the axis of symmetry, I should have a point 1 unit to the right of the axis of symmetry. So I can go ahead and put a point over here. Now, in the last video, I mentioned that the quadratic has a pattern for graphing of 1, 3, 5, 7, and so on. But this is only when a equals 1. What happens if my a equals -2? Well, if my a equals -2, I can just take -2 and multiply each of these values. So that means I will have the pattern of -2, comma, -6, comma, -10. What does that mean? It means from the vertex, my first point will be going down to right one or down to left one, which in fact it is based on the y-intercept and the symmetric point on the right. Next, from this point, I can go down 6. So I will go 1, 2, 3, 4, 5, 6, and it goes off the graph. But you could see that the next point would be down 6, right 1. All right, well, making a sketch of this graph, I will go ahead and just connect the points and draw a U-shaped graph. In this graph, we happen to have no x-intercepts. You can see that the graph does not touch the x-axis, so there are no x-intercepts. All right, the last thing I want to talk about is the domain. That domain is all real numbers. Remember, domain is all possible inputs. If we look at our equation, I could input any value I want into this x. Any value in the whole wide world could go in this x, and we would get an output for y. So we say the domain is all real numbers. The range, however, is going to depend on our k value, which is right here. Since the graph is opening down, then this vertex, which happens to be a maximum, so this is a maximum, it's the highest point on the graph. This is where we can start saying that the range is less than or equal to -1. So we can say the range is y is less than or equal to -1. Another way to write the range, as we have practiced before, since it's going down to -infinity, you always want to put your your lower bound on the left. So round bracket -infinity, comma, -1, and then a square bracket indicating that we include the point -1.